All right, here's a video of how to draw a ray diagram for a mirror. Now, what we start off with is this idea that our mirror, even though it's curved, we're going to give it a flat surface. That's what we call the thin mirror approximation. The reason for that is that it makes the geometry a lot easier. If the mirror is really curved, then the geometry gets a little more complex. So we'll just say that the mirror, instead of being curved, is flat. Here's our object over here, and this location, this horizontal location that goes through the object, through the what we call the focal point and the center of curvature, and through the middle of our mirror is called the principal axis. Okay, so let's look at some other geometry when it comes to our mirror. Now, I know it says here that this is a parabolic mirror, but that's kind of close to what we would call a spherical mirror. And a spherical mirror would have a center of curvature right in the middle of it. So if you think of this mirror as being this ginormous sphere, the middle of it would be here at the center of curvature. In between the center of curvature in our mirror would be what we call the focal point. So therefore, the focal length is right between the center of curvature and where we call the mirror. So the radius is equal to 2 focal lengths. Now let's look at some very important rays when it comes to our object. So here's our object, and remember we say there's an infinite number of light rays that come from it. So let's look at the infinite number of rays that come from the tip of our object. And specifically, let's look at one called the P ray. The P ray is represented by this blue line that goes parallel, therefore P, to our principal axis and hits our mirror. Then from the angle of reflection, it bounces off there and then goes through our focal point. So that's what the P ray does. It goes parallel, then bounces off of the mirror through our focal points. Our next ray is what I call the C ray. The F ray. So right there, the F ray. It goes through the focal point first, then it hits the mirror, and then it goes parallel and through a parallel to the principal axis. Okay. Finally, the C ray, or what I call the cheetah ray. The C ray goes from the tip of the object to the center, therefore it's given the term C, then reflects off of the center, then to that point there, and notice that all of our rays hit the same spot. So what happens is an image is made there that looks really similar to our object. So this image, though, is not exactly our object because our object is over here. Our image is over here. There's some very specific things we need to notice about it. First of all, notice that for this particular image, it is on the same side as the mirror, and it's between the center of curvature and the focal point. There's the center of curvature right there, and there's a focal point. And it's on the same side as the mirror as opposed to being over here. We're going to find that there are actually some other images that are over here. I know that's kind of crazy, but it actually can happen. Some characteristics we need to know about this image is that, first of all, it's smaller than our object. It's inverted or upside down. And it's real. And what we mean by being real is that the rays of light bounce off the mirror and actually go to our image. And we'll talk a little bit more about that later. So here's our object. These are the rays of light that come from it, bounce off the mirror, and make this real image that is smaller, inverted, and real.